Hello, hello, hello. This is your problem set 2.5 video key. What could be more exciting? Probably nothing. Number one, find the zeros. Remember, find the zeros is where you factor. It's weird that it says that. That probably shouldn't be there. It should just say find the zeros of this function. But you factor with your double bubbles here. And to find the zeros means find when it does equal 0. And then you set each factor equal to 0. So we're going to do x plus 3 equals 0. X plus 2 equals 0. So you get x equals negative 3. X equals negative 2. Graphically, these are our x-intercepts. There's a nicer handwritten key than the one I'm making currently. So if you want to flip back and forth from that, here's the handwritten version. Oh, I didn't even find the zeros on the handwritten version, so I guess that's good. How many zeros can a quadratic have? There are 3 answers. So if we're looking at x-intercepts, we can have 2 x-intercepts. We can have one where the graph just touches the x-axis and turns around, or where it doesn't touch the x-axis at all. It has no x-intercepts. Okay, if x squared equals 9, what is x? There are 2 answers here, and that is x can equal 3 or negative 3. And you can list your answers like this, or you can say, 2 answers like that, or you can use the shorthand notation plus or minus 3. And that is because when you square a negative, it also equals a positive. So 3 squared is 9, and negative 3 squared is also 9. Okay, now over here, mathematically what you actually do to solve that is to get rid of a square, you square root both sides. This number, 10, is not a perfect square, so we don't know what number squared equals 10. But if you square root both sides, then you get x equals square root of 10. But also, just like over here, how there were 2 answers, there's going to be 2 answers over here as well, because it doesn't matter if it's positive square root of 10 or negative square root of 10. When you square it, it's going to equal a positive 10. So anytime you introduce a square root to a problem, you have to do plus or minus. So like this problem, there's already a square root. I'm just asking you, hey, what's the square root of this? You just say a positive answer. But when you put the square root into the problem itself, so there was no square root here, as you solved it, you put the square root in there, then you need to put a plus or minus in there. Okay, number 4 is like number 3, except we have like some extra stuff going on here. But that's okay. What we got to do, we still have something squared right here because we have a square right there. So to undo the square, you square root both sides. I think I'll just squeeze it in up here, save a little time. And you have to square root this side as well. Since we square rooted that side, we need a plus or minus. So now this square cancels out, and you get x plus 3 equals plus or minus square root of 7. Then you just solve this like normal. We're just going to leave this answer like this. So solve this like normal to get x by itself, which by that I mean subtract 3, and you get x equals. Now you can write the square root first, but usually we write the number that's not square rooted first, and then like that. So you have 2 answers, negative 3 plus square root of 7, whatever that is. You can do that on a calculator, and you get negative 3 minus square root of 7. And you could do that on a calculator, but we're not using decimal answers on these problems. All right, number 5. I'm just going to go to the already filled out key to make this a little quicker. You should get, on this one, we're multiplying these first and getting 36, and the square root of 36 is 6. On part B, we're square rooting the numbers separately and then multiplying the answers together to get the same answer. So what we're supposed to notice here is that it doesn't matter if we multiply first or square root first. It's the same thing. So if I have the square root of 2 things multiplied together, I can square root them separately, and I should get the same answer. Same thing happens with division. Now this one actually probably makes more sense to make this a decimal, but these both equal 5/7, so these are the same answer, which means I can either divide and then square root it, or I can square root the numbers separately and then divide. So in general, these rules are written like this. Hey, if we have 2 numbers multiplied together under a square root, we can just square root them separately. Or if we have 2 numbers divided by each other under a square root, we can square root those numbers separately and then divide. Up here, we can square root them and then multiply. So that's what's going on there. All right, to simplify radicals, we take a perfect square factor. So 50 is the same as 25 times 2. And then based on what we just talked about from above, we can square root each of these numbers separately. So this is, you don't have to show this step, but it's the thought process. So we can square root these numbers separately. And then we know that the square root of 25 is in fact 5. The square root of 2 we don't know, and so we just leave it under the square root. On B, now B I'm not going to do it the fastest way possible because I want to show you what happens if you don't. But if you choose the greatest perfect square factor of 128, then your first answer will be the right answer and be all the way simplified. But I'm going to just divide this by 4, and I get 4 times 32. Okay, 4 is a perfect square, so I can square root the 4 and make it 2, and then the 32 stays under the square root. But now I have to see if I can do with the 32 what I just did with the 28. And if I can, then I got to keep going. And in this case I can because this 2 just stays here. This 2 is going to stay out here. And then 32 is the square root of 16 times 2. And I know the square root of 16, so now I can do the square root of 16, which is 4, and then keep this 2 under the square root. So this turned into 4, and this 2 stayed the same. Whenever that happens, and you already have a number out here, you multiply these two numbers together. So our final answer is 8 square root of 2. The shortest way to do this one would have been to recognize right away that this is 64 times 2, and then the square root of 64 is 8, and then the 2 stays under the radical. Okay, on C, it's a fraction, so we can just square root them separately. Square root of 6 we don't know, square root of 49 is 7. And that's all there is to it on that one. On D, now you could actually divide these first. That's something we know we can do. We can divide this first and then square root them, or we can square root them and then divide. I'm going to square root and then divide because this is a perfect square. So I don't want to get rid of that. So I'm going to do square root of 12 over square root of 100, which is 10. Then we got to simplify the square root of 12, if possible. And it is possible because 12 is 4 times 3. The square root of 4 we know is 2. We don't know the square root of 3, so it stays under the square root, over 10. Then we can reduce these two numbers like any normal fraction. It's like saying 2/10. And 2/10 is the same as 1/5. And there's a 1 here that I'm not going to write, but that's your final answer right there. Okay, same thing on E here. I don't want to divide first because this number is a perfect square. So I'm going to do the square root of 24 over the square root of 64, which is 8. Square root of 24, though, is 24 is 6 times 4. That's still over 8. I know the square root of 4 is 2. And I don't know the square root of 6, so it stays under there. And then again, we can reduce the 2 and the 8 to 1 and 4. And you get that. You won't always have a 1 here. Sometimes you can have, like if this was a 4 to begin with, or sorry, like a 6, then you would get, like 6 over 8 would be 3/4. You would have a 3 right here. So it's not always going to be a 1. All right, this one, neither of these are perfect squares, and they don't have any perfect square factors because this is just 2 times 3 or 5 times 3. So then I'm going to multiply the numbers together first. So this is the same as the square root of 6 times 15. That's something we can do, which is the square root of 90, because that's this property right here. Whoops, which is on the handwritten key. That's just me doing this. The problem started like this, and so I rewrote it like that. So now the square root of 90, hopefully you realize, is 9 times 10. The square root of 9 is 3, and the square root of 10 we don't know. And 10 is only 5 times 2, neither of which is a perfect square, so we just keep it like that. All right, the next problem, if we have a square root on the bottom, it's not considered to be simplified. So we have to do what's called rationalize the denominator. And what we do here is multiply. You can multiply the top and bottom of a fraction by the same number without changing the value of the fraction. So that's what we're going to do here. If I multiply this by itself, the square root will go away. So I'm going to multiply top and bottom by square root of 6, making the numerator square root of 30, and the denominator becomes, you can skip this step, but it's going to be the square root of 36. But the square root of 36 is, in fact, 6, which is why we chose to multiply this number to begin with, because notice how my answer just became 6, which was the number under here. So if you multiply a square root by itself, that's the same thing as squaring a square root, and squaring a square root gets rid of the square root. So that's called rationalizing the denominator. And you always got to do that. If you have a square root on the bottom, you got to go through this process. It is used for a greater purpose in some later math classes. We won't actually use it for a greater purpose in Algebra 2, but it is just the first time that you learn it. So on this one is what we're going to do on number 12. We're going to make it look like number 2. So if it's just x squared equals a number, now technically on this problem what we really did is square rooted both sides. So we really did this, like square root of x squared, square root of 9. We square root both sides, and we got to put a plus or minus since we did that. So if we get x squared by itself, then we can do that. So so first we got to add 1, and you get 3x squared equals 26. Divide by 3, and you get x squared equals 26 thirds. Now we can square root both sides. So I need a plus or minus because I put the square root into the problem. You get x equals plus or minus the square root of 26 over 3. Well, that's the same as plus or minus the square root of 26 over the square root of 3. So we have a square root on the bottom, which means we have to rationalize, which is what we just did. Multiply top and bottom by this bottom. And now you have square root of 26 times 3, square root of 3. And that is whatever 26 times 3 is, which is 78. So you get square root of 78 divided by 3. And it's all plus or minus because of this plus or minus right here. And then 78, you got to see if there's a perfect square factor. There isn't, so I'll save you some time and let you know that there isn't. So there you go. Same exact work really there. And now this, what's being squared here, is this whole thing. So we got to get this thing by itself, which is then going to make it look like problem number 4. So we're trying to make it look like problem number 4. So we got to get rid of these extra numbers first. In this case, there's just this number. We got to get rid of the 1/4. So the first thing you can do is you can divide by 1/4 or multiply by 4. It's kind of the same thing. So I'm going to multiply by 4 on both sides, which will cancel here. Multiply by 4 over here, and you get x plus 6 squared equals 36. Now we have the thing that's being squared, the thing right here, that's being squared all by itself. So now we can square root both sides. And since I square root both sides, I got to squeeze a plus or minus in there. The square cancels, which is the point of square rooting, and I get plus or minus 6. And then now you got to get rid of this 6. I got this, by the way, because that's the square root of 36. Get rid of this 6 by subtracting. So you get x equals -6 plus or minus 6. Then we can't leave our answer like this because these are actual numbers. So we're just going to do -6 plus 6 and -6 minus 6. So you figure out your two answers by doing that. So one answer is -6 plus 6, which is 0. The other answer is -6 minus 6, which is -12. So we get x equals 0, -12. Two different x answers, two different values for x that make this equation true. Okay, number 14 says, we're just going to apply a word problem here. When an object is dropped, its speed continuously increases. What happens to the object's height above the ground as the object's speed increases? So you're just dropping something. Here's the ground, something's falling. So what happens to its height? Well, its height decreases. So the height of an object after it is dropped can be modeled by this equation, where h sub 0 it's called. This is called a subscript. So we just say h sub 0 is how you read that. So those of you who play Mortal Kombat, sub 0. They're not related. Where h sub 0 is the object's initial height and air resistance is ignored. If we do air resistance, like wind resistance, this equation gets more complex. So we ignore it as we first learn this material. And in fact, we'll ignore it for all of Algebra 2. But h sub 0 is the initial height. So all we're going to do is find the initial height in some problem and put it in here. So this says, Tyler thought it would be fun to play a prank on some people, so he dropped a water balloon from the top of a bridge that is 500 feet above the ground. So this is our h sub 0. So we're going to plug that in right here. How long did it take for Tyler's balloon to hit the ground? Well, that's when the height is 0. So the height is negative 16t squared plus 500. So this gives us the height at different times. This is our time. So if I plug in t equals 3, I know exactly how high the balloon is after 3 seconds. So we want to know when it hits the ground. So we want to know when 0 equals negative 16t squared plus 500. We want our height to be 0. Okay, so notice how we have just one thing being squared here. There's only one variable in this problem, so we've got to get this thing by itself. So subtract 500, and you get negative 16t squared equals negative 500. Divide by negative 16, giving us t squared equals whatever 500 over 16 is. Let's flip over to this key where I already have it worked out. Oh, so I didn't actually show it yet. Okay. So we get 500 over 16. And then to get rid of the square, you square root both sides. Now we don't need a plus or minus on this problem because time has to be positive. So for a real world problem, only the positive answer makes sense here. So that means t equals square root of 500 over square root of 16, which is the same as square root of 500 over 4, because that's a perfect square. Then you can find a perfect square factor of 500 and go through our simplifying process. But in a real world problem, it probably makes more sense to have a decimal answer. So you could really just take, unless I tell you to like not use decimals on a word problem, you can just take this part right here and put it in a calculator. Here's how we would simplify it if I just gave you this problem, said, hey, solve. But in a word problem, like, what in the world does this answer mean in terms of time? Like, nobody's going to know what that means. So it makes more sense to actually have an estimated like decimal answer. And then the last part is, I'm just going to show it to you here on the key. But it says Jordan, a 6-foot-tall friend of Tyler, spotted Tyler above the bridge and knew he was going to throw a water balloon at his head. How long did Jordan have to get out of the way of the water balloon after Tyler threw it? So now we want to know how long it's going to take before the height is 6, because Jordan's 6 feet tall. So if Jordan's just standing there, we want to know how long it takes the balloon to get to a height of 6 feet. So you just set this equal to 6, and you go through all the same work. Subtract 500, so we did that here. Divide by negative 16, so you get that here. And then you can just do this on a calculator. Really, you can do this on a calculator. The 4 came from me square rooting that 16 right there. But in any case, you get that many seconds. And that's it.